Good day once again. My name is Graphics. Today we'll be looking at stress and strain. Now, stress and strain are fundamental concepts that is used to describe how a body responds to external load. Right? So we know that every compound or every body, every component experiences some form of what? Of loading. Is that okay now? Now let's take stress for instance. Now you say stress is the force of resistance offered by a body against deformation. Now if I have a body like this, let me say this is a body that I have like this, right? And I am applying stress, that means putting a force on that body, right? Now in that body, the body will develop an internal resistance that will want to stop it from what? From deforming. Is that okay now? So we'll call that internal force the force of what? Resistance. Now if I section this way, let's put it this way, one part of the section, force P, right? Now the force of resistance will be opposing the direction of the force. Now we'll call this kind of force uniaxial force because of what? They are acting on the same axis. Is that okay now? Now this is the force of resistance that tends to oppose this material from what? From deforming. Now if I move further at the other part too, the same thing is happening. This is the force and there's a force of resistance that is trying to oppose it. Is that okay now? Let's say this is A and this is B. So this is the B part, this is the A part. So the internal resistance, the internal force that is developed from avoiding this material from deforming is what we call stress. Are we good? So one thing you need to understand is that what? Stress is given by the symbol sigma, right? And is given as what? Force over what? Over area. Is that okay now? And the unit for stress is what? Unit per what? Meter square. And you can also say stress is the internal force of resistance to deformation per unit cross-sectional area. The force of resistance to deformation per what? Per unit cross-sectional area. When I mean cross-sectional area is this. Now if I have this my material this way, right? If I have the material this way and I have a force that is applied to it, is that taken? If I cut it, I apply a cutting to here and I cut it this way, looking at this direction, X. Now what will I see? I'm going to see something like this. I will see something like this. So this section here is called our A naught, right? We'll call it what? A naught, cross-sectional area. Like when you cut it into two, it's showing the thickness. The thickness is what we call cross-sectional what? Cross-sectional area. Is that okay now? Now we can also say is the measure of what? Internal force per unit area, right? And it's given in what? In Pascal. So Pascal can also be Newton per what? Meter square. Any of the two. Now look at this now. We're moving forward. We have types of stress. Types of stress. There are different types of stress. There's one we call the direct stress, which can be the tensile stress and compressive stress. So let's start with what? The tensile stress. Let's start with what? The tensile stress. Let's start with the tensile stress. Now, the tensile stress is an equal and opposite pull force that tends to what? Increase the length of what? Of a material. Now, let me say I have a body this way, right? And that body I am applying a tensile stress. So this is a tensile stress. It's an outward force. It's a pull force, right? Let's call it P or call it F, any of them. Now this stress has the ability to increase, right, or decrease, to increase the length of this material. So we'll call this point our what? Our original length, or you call it our initial length. Is that taken? And you call the elongation here, you call it L plus what? Or I can L plus what? The LO, right? Depend on what you want to use. So I'm taking my LO here to be my original length and my L to be my increase in length. Is that taken now? Now we also call it delta L. So in this case now it will be the original length minus what? The increase in length. Is that taken? So you call this the L, then delta L, right? Let's put it this way. So the L plus delta L, that is for that aspect. So one thing you need to understand is that the stress, the force that is applied to this material can increase the material or can leave the material the way it is, depending on what? The internal force of resistance. If it doesn't fail, the material remains intact. If it fail, that means it will increase the material. Is that taken now? That is for tensile stress. So we say that our stress tensile is equals to what? The force over what? The area. So my subscript 3 means what? It is tensile stress. Is that taken? So now the next thing we're talking about